All right, so here's the last kind of problem on section 5-1. And every year I tell students this is the easiest concept for students to understand. However, it can be one of the most frustrating things that you'll probably do in this entire lesson, maybe possibly even this entire unit. And that is, you can actually use a table of values, a pairing of x and y's, to be able to figure out what the degree of the polynomial function that would generate that data. In other words, blah, blah, blah. Let's get down to it. There was some function, some polynomial function. Let me go back and show you this right here. So you got a whole bunch of polynomials here. If you were to graph that function, you get a whole bunch of x's and y's. So I put a whole bunch of y equals 5 or y equals x plus 4 or y equals 4x squared. What you'd be able to do, and what this is actually telling you, is that if you were to look at a table of values, there's actually a way to figure out if this table is actually a linear function, a quadratic function, or a cubic function, or quartic or quintic, or any other degree higher than that. All you have to do is find the differences of the y values, okay? So here you have the table shown right over here, and look at those y values right there. All they did is copied those y values right here, okay? There's all of them. And so what they did is they found the difference here. Now the difference can be found two different ways, okay? If you want to do this calculator based, the way that you would do it is you would always take the second term and subtract the one before it. So watch how I very carefully do that. I take negative 7 and I subtract the term before it, which is negative 1. Do you see how negative 7 minus a negative 1 actually adds 1 to a negative 7? That's why you see a negative 6. That is one way you could do it. Okay? The other way I kind of coach students up at doing it is just asking you this. Take a look at that number line. You're watching this video on the big screen. Look at one of those number lines to the left or to the right. Spot negative 1. And then spot negative 7. Did you go up or did you go down? Right? We went down. How far down did you go when you went from negative 1 to negative 7? Do you see how we went down 6? So I indicate that by using a negative 6. If we were to continue to do that for the rest of these problems, I go from negative 7 to a negative 3. Did I go up or did I go down? Look at the number line. Oh wait, I went up 4. Here's one thing that the textbook does not do that I would hope that you would do to maybe make life a little bit easier here. If it is an increase, go ahead and put a positive sign there to indicate that that is an increase. So we repeat that process. Negative 3 to 5, that's an increase of 8. Remember the other way you can do it? You can do 5 minus the one before it. And you see how that would create a positive 8 right there. Okay? So we repeat this process, finding those first differences. And what you notice about the first differences as they continue here is that none of them are the same. If the differences are not the same, what that tells you is that after the first differences, that means that this guy right here is not a linear function. It's not a straight line. So then you take those differences and you find the difference between those. So if I'm going from negative 6 to positive 4, see why I had the positive here? Look at the number line, go from negative 6 to positive 4, that's an increase of 10. Okay? Positive 4 to positive 8, that's an increase of 4. Positive 8 to a positive 6, that's a decrease of 2. So indicate that with a negative 2. Positive 6 to negative 2, decrease of 8. Negative 2 to negative 16, a decrease of 14. So once again, second differences. So guess what gets ruled out now? Quadratics. No can do. Look what happens when you go on to the third differences. The third differences, if you do it properly, gives us the same amount each and every time. So since the third differences are constant, the third differences indicate that we have a third degree function, aka this is a cubic function that would have created that table of values right there. Very easy concept because all we're doing is just doing differences. But it can be the most frustrating thing in the world when you're looking at this. It's very tough to get those numbers right because sometimes if you're not paying attention to the positives and negatives, mistakes can happen. So here's what I'd like you to do. And teacher, help me out. Substitute, help me out. What I want you guys to do right now on this problem is find just the first differences. Let's pause the video and give you guys a chance to do the first differences, and then we will check. All right, so take a look at mine. I tried double checking it a couple times just to make sure. How'd you do? If you made any mistakes here, take the time right now, clean it up. Okay? We'll pause the video again, The reason why we have to pause the video again is because look at this. First differences are not constant, so it's not linear. So let's go ahead and continue again. Let's get second differences. All right, take a look at that. How'd you do? Do you see why we still need to continue? The second differences are not constant. So we'll pause it again. Get those third differences. Take a look at those. Still not the same. Starts to get a little bit annoying, but let's see. I think I got a good feeling about this next one. Get those fourth differences. Let's actually watch me do these fourth differences. If I go from negative 36 to negative 12, that's an increase, right? An increase of how much? I think that's an increase of 24, right? And then if I go from negative 12 to positive 12, look at the number line up there on the board. Going from negative 12 to positive 12, that's also an increase of 24. So far, so good. 12 to 36, that's another increase of 24. Hooray. We can stop. The reason why we can stop is because we got the same number each time. So here's a mistake that a lot of students make when it comes to nailing down the differences. A lot of students count this as the first difference. Nope, don't count that as the first difference. First differences don't start counting until you write those numbers in there. So that's the first difference. There's the second difference. There's the third difference. There's the fourth differences. So the degree, it would be a fourth degree polynomial, aka quartic. Okay, so there's lesson 5.1. You guys have the homework log. Good luck.